In this video, I will code a Ludo game using JavaScript, where you will be playing against the highly competitive bots, making the experience more challenging and engaging. Just like the traditional Ludo, the goal is to move your piece across the board, unlock them, and reach the center before your opponent does. The game includes all classic features like unlocking the pieces, knocking out your opponent pieces when you land on the same spot, and racing towards the finish line to win. Our bot isn't just there for a show, it's designed to play strategically and can make some sharp moves, giving you a real challenge. Now let's dive into the gameplay and see how it works in action. As you can see, we start by rolling the dice. Once you roll a 6, you can unlock one of your pieces. Here, I have unlocked my first piece and the race begins. The chance is moved to the next team after every move. Notice how the bot makes calculated moves. It is quick to unlock pieces as well and strategically places them to knock out your pieces when possible. As the game progresses, you will need to plan your moves carefully to avoid getting knocked out by the bots. Once you complete the journey with all your pieces, you will be emerged as the winner. And that's the basic rundown of the game mechanics. You versus smart bots. Let's now see how you can build this game step by step in JavaScript. There are a few prerequisites you will need to have to follow along smoothly. First, a solid understanding of CSS grid is essential, as the entire design of this Ludo board revolves around it. You should have basic JavaScript knowledge, including loops, functions, and working with classes too. The design part is primarily focused on creating a grid. The Ludo board is structured as a 5x5 grid. In this grid, the top two boxes and the two boxes below them are designated as the red board section, while the next to it is for a path, and the same applies for the green board and path 2. Each path container will consist of 18 boxes in total. Understanding how each part of this grid is divided into boards and paths is crucial to mastering the design. Don't worry if it seems a bit complex right now. Once I start building the board with CSS, everything will become much clearer. One key thing to note, I will explain each concept step by step before we move on to the coding. So stick with the video till the end and get the full picture. I have already set up the project by importing the necessary CSS and script files. Now to add some stylish icons for the game pieces, I will quickly grab the Font Awesome seeding link. Copy and paste this into the head section. And with that, we are ready to move on to the actual design process. I have already imported the font we will be using and initialize the root variables to keep everything organized. Now in HTML file, I will start by creating a parent div with a class Ludo container. Inside this, I will add another div with ID Ludo board. This element will be the core of our game, the main board that holds all the boards and paths for the pieces. This path div on the board will each have 18 square elements, just like the traditional game board. I will continue writing the HTML structure as explained. This will have total of 18 div elements with class LudoBox. And now I will add a div with ID green board and class board. Don't get confused why I have not created the red path element near the red board. It will get fixed when I will add CSS. A win zone ID for the element that will be in center. And now both the path elements will have the same 18 div elements of class LudoBox. Next, let's move back to the styling. Starting with the container. For this container, I am giving it full width and height and centering all the items inside to make sure everything aligns perfectly. Now, for the Ludo board, this element will have a set width and height with white background and will be displayed using CSS grid. The tricky part here is setting up the grid template areas, as this forms the backbone of the design board. Let me explain it clearly. In this template, assume this as a 5x5 grid. I am assigning names to the different sections. For instance, red board is mentioned twice, meaning that the element having grid area name as red board will occupy two grid compartments from the first row, followed by green path and so on for the other sections of the board. In hope you understand the point, I will go ahead with this. Now I will assign these grid areas to the respective board IDs. Let's style the boards now. Starting with the red board, setting grid area as red board as mentioned above. And I will do the same for the other paths and boards. You won't be able to see them yet because we haven't added styles for the individual boxes and paths. Next, I will start adding divs to the place and game pieces and style them accordingly. Each of these divs will form a 2x2 grid for holding 4 pieces of the team. The spans inside will act as a background for each piece. They aren't showing it because we still need to add background style for these spans. Let me quickly apply those changes. Give me a moment to show how board looks now with all element styles. As you can see, it's starting to come together. Next, I will style the Ludo box, which is the container for the pieces, and apply styles to the individual game pieces too. I'm adding a slight transform property to lift the pieces above the board slightly, and I have applied a stroke effect for better visibility. There's also an animation for the pop-up effect when the pieces are moving on the board path. The red Ludo box is the home path and entry path, and same will be applied to other teams as well. Now this particular styling is for the game pieces that will be dynamically added through JavaScript. There's also an active class I've applied for the glowing effect, which highlights the board whose turn it is. For example, when it's the blue team turn, the blue board will light up. This happens for each team turns as well. At a point, I noticed a small issue. The problem was due to the incorrect spelling of green path. Also double check your code for typos. Now let me show you how the pieces look on the board after all the styling. It's looking great. So let's now move on to the logic part, where I'll assign IDs to the Ludo box elements. This is our complete Ludo board, and this spot will be the starting point of the red team when the piece is unlocked, right? And now I will give this element an ID of R1, which will help JavaScript track where each piece is located on the board once it's unlocked. I will continue assigning the IDs to the other path elements like R2, R3, all the way up to R13. I will show you how to move pieces on this path later in the JavaScript section. The same logic will apply to the other teams, starting with G1 for green, Y1 for yellow, B1 for blue, and all the way up to G13, Y13, and B13, respectively. You will need to manually assign these IDs to all these elements, as these are just one-time process. For now, I will move on giving IDs to the individual boxes. Watch closely as I assign IDs to each element, and make sure to follow the same process. You will need to have some patience here. This is time consuming but crucial step, and again it's a one time effort, but it's well worth it to make sure the game runs smoothly. You will need to assign it in series as I explained. Once all the elements have their IDs, I will color the boxes accordingly to the respective teams. Again, follow along how I find the elements and assign the proper team colors. With that, we have almost completed the design part. We still need to assign IDs to the final path elements, as these will also be used for the game pieces during gameplay. Now let's move on to the game logic, starting with importing all the board elements. Next, I will create a class called player pieces, which will represent the game pieces. In the constructor, I will define its properties: team, position, score, home path entry, player ID, and game entry. This will form the core attributes of each piece. I will also add a status variable, which will indicate whether the piece is unlocked or not, where 0 represents locked pieces and 1 means it's unlocked. The initial position property will store the starting position of the piece on the board, which we will be used to return the piece to its start position if it's killed. Now let's define a few functions. Unlock pieces. This will set the status of piece to 1. Update position. This will update the current position of the piece. Move piece. This will handle the movement logic for the piece. For now, I will leave this function empty. Send me to board. This will reset the piece to its initial position if it's killed during the game. After defining the classes, I will declare some global variables that will be used throughout the game. Player turns, an array to store sequence of player turns based on their team color. Current player turn index and previous player turn index. This will track the current and previous player turns. Current player turn status, a boolean variable that will check whether the current player has played that turn or not. Team has bonus, a flag set to true when the team kills another pieces or reaches the home. Dice result, a variable to store result of the dice rolled. Let's initialize the game variables. First, I will prompt the user to input how many players will be playing. Let numpvp is equal to prompt enter number of players. Next, I will create player pieces array to store all the pieces for every team. And the board details array to hold the board details for each team, such as team color, board element, home entry, and game entry. In the next step, we will run a for loop to add pieces to the game board. This loop will include a nested loop to add 4 pieces per team. First, I will declare a variable for board color, home entry, and game entry. I will create a span element to represent each piece of the board, and within it an icon element using font awesome icon to represent the game piece. Then I will add an event listener to each icon, so when the user clicks on the piece, it will trigger the piece movement logic, which I will implement later. I will set the game piece ID based on its team and the position, and create a player piece object for this piece, passing with appropriate values. Lastly, I will append the icon to the span and the span to the board element. Next, I will set the player turns array to define the order of turns. If this is equal to 2, the turns will alternate between blue and green teams. If it's 3, it will include blue, red, and green. And finally, for 4 players, the turn will cycle between blue, red, green, and yellow. This array will be crucial in switching turns between players. Now let's code the logic to switch turns between the teams. We are also including sound effects in the game, and you will find all the source code and audio files in the description link. Next, I will create a helper function called delay to manage the slight delays we want for smoother gameplay. This function will take milliseconds as an argument and return a promise that resolves after a specific time using set timeout. To add a glowing effect to highlight the active player board, I will write a set player turn function. This function will add an active class to the current player's board. Now let's set the initial active class on the blue board, which marks the starting player turn. It seems like something went wrong. I found an error. The issue is that the numpvp value it's been treated as a string. So I will add a pass in to convert it into a number. Now the glow effect is working perfectly. Next, I will create a next team term function to shift the turn to the next player. I will use previous player turn index to remove the active class from the previous board and then use the small delay before setting the next turn. I will also include a condition. If it's not user turn, the dice will automatically roll to the bot. And finally, I will call set player turn twice. First to remove the active class from the previous board and then set to the current player board. Everything is going great so far. Now let's move on to the next part, the logic for the roll dice button. This is one of the key interactive elements of the game. So let's break it down. I will start by adding a GIF to show the dice rolling animation. For that, I will declare a variable to represent the image element and set the source of that element to the GIF in my assets folder. You can find everything related to this in the source code, so don't worry about the assets. Now just for convenience, I am going to set the variable numpvp to 4 since we are going to be playing a 4-player game throughout the building process. Let's keep simple for now, but you could adjust it if you want the game more flexible. Next, let's set up the DOM elements for the roll dice button and the dice image. This will let us interact with the button and the image using JavaScript. Now that we have got the variable set up, let's move on to adding the event listener for the button. This listener will trigger the dice roll when clicked. But here's a small catch. We need to make sure that the button doesn't click again if the user has already taken their turn. To do that, I am going to set up a condition that checks if the user has already rolled, and if so, it will just return and do nothing. This prevents them from getting another chance. I will also disable the button once it clicks so users can't spam it. And as I mentioned before, we will change the dice image source to the rolling GIF so users can see that something is happening. To simulate the rolling of the dice, I will use the JavaScript math.random function to generate a random result between 1 and 6. Once the result is generated, I will set the current player turn status variable to false because it's no longer this player turn, and I will set the team bonus to false as well. Now let's add a little delay. I'm using a set timeout function here, which will set the dice image source with the match result after 700 milliseconds delay. This makes the game feel more interactive, like the dice that are actually rolling in real time. At this point, the button might not work as expected, and that's because the current player turn status variable isn't being updated correctly. I will go ahead and fix them in a moment. Next, let's handle a situation where the dice roll is not a 6 and the player has no unlocked pieces. If that's the case, it means the player can't make any moves. So we will move on to the next player turn. This adds a bit of strategy to the game because you can't just keep rolling the dice endlessly. To check for unlocked pieces, I will filter through the player's pieces and look for those that are unlocked. We will filter the pieces based on the player's data. Oh, and there's a small bug here. I need to make sure that I am accessing the length of the total unlocked pieces variable. Fix that in the code so we don't run into any issues. Now that we have covered, let's move on to implementing the bot's dice rolling. I will create a similar function for the bot called roll dice button for bot. The logic here is mostly the same, but with some additional tweaks for the bot player behavior. Now let's define the path array variable, which will contain all the possible paths of the board. If you remember the game layout, you will recognize the different sections of the board, like the home stretch, the safe zones, and the path each piece can take. Next, I will create the home path entries object. This contains specific paths for the each team home. This is important because the players will need to move their pieces to their home area to finish the game, and I need to keep track of those paths separately. Along with that, I'm going to define a safe path array for the safe zones of the board. You know, those special spots where the piece can't be captured by the opponent. And lastly, I will also define a home path array. This will represent the path a piece takes when it's nearing to its home base. These variables will help us build the logic for the moving piece. Later on, I will explain exactly how they work as we code the movement logic. Now let's implement the turn for user function. This will be triggered whenever the user clicks on one of their pieces. First, we will check if it's the user turn, and if not, we will just return and do nothing. This ensures that the player can only make a move when it's their turn. To find the piece that the user has clicked on, I will search for the piece by its piece ID attribute. This makes it easy to identify which piece was selected and which player's piece it is. Once we have identified the click piece, we need to calculate its moving path. This is where the give array for moving path function comes into play. Let me explain you how it works. Imagine this scenario. The game is running and the user clicks on the roll dice button. The result of the roll is 4. Now the user clicks on the piece. The current position of the piece is R5. And since the dice roll was 4, we want this piece to move to the position R9. The give array for moving path function will calculate the path for the piece to move by using the path array. It will return an array like R6, R7, R8, R9, and this is the path the piece will follow. Once we have the moving path array, I will create another function to actually move the piece along the path. This will update the piece position on the board. But there's one more thing we need to account for. If the piece is currently in the home path, it will follow a differently set of rules. So I will use the home path entries object to determine if the piece is in the home stretch. If it is, the logic will treat it differently. Now that we have the moving path, I will check if the path length is less than the dice result. If the dice result is 6, the player gets another chance to roll. So I will set the current player turn status to true. If the piece is locked, I will unlock it. Otherwise, it will just move the piece according to the calculated path. For now, let's set the dice result to 6 temporarily so we can test the logic. This will help us verify that the unlocking movement of the piece are working expected. Next, I will going to write the logic to unlock the piece. If the piece is locked, we need to set its position to the game entry position and move the piece onto the board. This is crucial step of the game because players can't start moving their pieces until they are unlocked. And lastly, let's talk about the move piece function. To move a piece, I will create a separate function called move element sequentially. This will allow me to move the piece smoothly from one position to another step by step. So let's now move on to the move element sequentially function. First things first, I'm going to grab the DOM element of the piece that's supposed to move. I will store that in a variable called element to move. This will give me direct access to the piece I want to move. Next up, we need to figure out whose turn it is. To do that, I will get the current player turn and find the piece object from the player pieces array. The logic here is simple. Now, moving the piece itself is where it gets interesting. I will be using recursive function for this, which takes the path array as one of its parameters. The array tells us the sequence of the position the piece should follow. So the first thing the function will do is check if the pieces has reached the home position. If it has, I will remove the piece from the player pieces array. If the current player turn is blue, which means it's actually the human player turn and not the bot's, I will set the current player's turn status to true. Otherwise, I will call the rollMyDice function, which we will get into it later. Now we need to update the piece position after every move. This is where the magic happens. I will call the update position method from the class to update the DOM and visually move the piece. Then I will append the piece to its current target on the board. I will also introduce a timeout here to create a slight delay before piece moves. This helps to make the movement feel more realistic and improve the overall user experience. A small gap in the action is great for keeping things engaging. As for recursive function, I will make sure the base case is checked carefully. If toBreak isn't true, the function will call itself again to continue the movement. This keeps things going until the piece either reaches the home or this condition breaks the loop. We hit an error. There's a bug I need to fix. The turn for bot function needs to be uncommented in this logic. Let's go ahead and create that function now. First, I will get the current player's turn team and then look at how many pieces are currently unlocked. Now here's where the actual bot logic begins. If the bot hasn't unlocked any pieces yet and the dice roll isn't a 6, I will simply call the roll my dice to pass the chance to the next team. The interesting part here is when the pieces reaches the home. There's a bonus mechanic. So if the piece reaches the home, I will pass a true as an argument to the roll my dice function. This tells that a bonus should be applied. I will also add a delay of 700 milliseconds after the dice rolled, just to make sure there's a slight pause before bot proceeds to its next move. That way, it feels less robotic and more like a turn-based game. Now, before the user or a bot had played their chance, I will check if the user has met any of these specific conditions for their turn. If they do, I will give them a one more chance. Now let's create a helper function called ovMyPiece. This is going to be used multiple times in the turn for bot function. So having it as a separate function makes the code much clearer and reusable. In this function, I need to check if the length of the path is less than the dice result. If it is, I will just return false and stop the move. If you know the importance of this condition, please let me know in comments. Once that's verified, I will simply call the movePiece function from the piece class to animate the movement. Okay, now that we are moving along, let's talk about how the bot unlocks its pieces. First, I will set the current player turn status to true. Then, I will check if the bot has no unlocked pieces and if the dice result no unlocked pieces. And if the dice roll is 6, then I will check if the bot has no unlocked pieces and if the dice roll is a 6. If both conditions are met, I will unlock the bot's first piece. We ran into an error earlier while doing this, so I will try to debug it by logging the values to the console. This will let me know if the variables are being populated correctly. Okay, now it's working. I will add the logic for kill detection later. Now let's move on to the decision making process for the bot. The logic here is pretty simple. If the bot only has one unlock pieces, it will obviously move that one piece. No decision needed here. If the dice roll is 6 and bot only has one piece unlocked, it will unlock another piece. But things get a bit more interesting when the bot has two unlocked pieces. I will need to check if bot has 3 or fewer unlocked pieces. And if the dice roll is 6, if this is the case, it will unlock another piece, just like before. There's an error here. We will debug it. Maybe we have passed the wrong ID when accessing the DOM element. This can happen, so double checking is always a good practice. Now that the bot has two pieces unlocked, I will introduce a little strategy to decide which piece to move. Here's how it works. First, I will check the number of safe pieces and unsafe pieces. I can do this by filtering the pieces and checking their position against a safe path array we declared above. If no safe pieces are available, I will choose the piece with the highest score You know the ones that farthest along the board. If there's exactly one piece safe, then of course the bot will move the unsafe piece. If there are two safe pieces, I will check if they are on the same position. If they are, I will just move any of them randomly. But if they are on different positions, the bot will choose the piece that has fewer opponent pieces back of it. To do this, I will create a helper function called giveAnyways behind me, which checks how many pieces from the opponent team are behind the bot's piece on the board. That covers the overall bot logic and how we move piece around. But stay tuned because there's more to come, including kill detection and few other edge cases. We are almost there, so let's keep going. Again, the same basic concept as before, where I first get the team turn. Now, here we are going to calculate the index of the path of the piece that we have received from the parameters. By getting the path index, we can determine the last 6 path elements. The path index is the path index is essential because each piece moves in a specific order, and tracking that will allow us to make the right decisions during the gameplay. Next step, to calculate the enemies behind the piece, I will start by creating a for loop. This loop will iterate through the board and check all the positions behind our current piece. I will store the path generated by this loop in the last 6 path array. This array will be really useful later. With that done, we now need to determine if there are any opponents on the path behind the piece. For this, I will use filter method on the player pieces array. This allows us to easily find any opponent pieces that might be standing behind us. If an opponent's position is included in the last 6 path array, we need to take that into account. Now, as I said earlier, the goal here is to move the piece that has fewer opponents behind it. This strategy will help minimize the risk of getting caught by an opponent, so the bot makes smarter decisions by avoiding high risk. Once we have this logic in the place and everything is functioning smoothly, it's time to ramp things up. Let's move on teaching the bot what to do when it has three pieces unlocked. This is where the bot's strategy needs to get a little more sophisticated. The idea here is again to calculate the safe and unsafe pieces. Those pieces that are in the position where they can move forward without encountering too many opponents. I will apply the same logic we used before to determine which piece are in danger and which one are in safe. Then we will move the piece with the greatest score. This makes sure that the bot moves its highest scoring pieces first, which maximizes its chance of winning. At this point, the logic should be clear. We are focusing on minimizing the risk, maximizing the bot's score, and making strategic moves based on the state of the game. The if not this, then do that principle comes into play here, making the bot's decision making process both straightforward and efficient. It's all about applying simple rules that allow the bot to act intelligently without being overly complicated. This scenario requires a high level of strategy. Since the bot has multiple options, but we can still stick to the same principle. Calculate the safe and unsafe pieces, then choose the piece with the greatest score. As you can see, the code we have developed so far is very understandable. It mainly relies on simple conditions to guide the bot's behavior. Given that it's all based on conditions, I don't think there's a need to go into much more detail about the logic. You can follow the flow and understand the key decisions, points, and drive that bot's move. So let's continue with this and make sure we get the bot's behavior right. That's it. We have laid out the basic principles, and now we can forward to implement these strategies step by step. Let's move ahead and write the logic for detecting kill in our Ludo game. Don't worry, it's straightforward once you understand the process. Imagine this scenario. A red piece is currently at position G6 and a opponent's piece is sitting at position G10. Now let's say you roll the dice and the result is 4. How do we determine if the red piece can kill the opponent piece? It's simple. Here's the plan. Once the dice is rolled, we start a for loop. This loop will iterate based on the number of unlocked pieces for the current team. Now remember the give array for moving path function? This function generates an array of positions that a piece can move through. Since the dice result is 4, the moving path array for our red piece will look like this. The key here is to take the last element of this array. In this case, it's G10. Next, we will filter the opponent's piece from the player pieces array and check if any of them are positioned at G10. If we find a match, that's the opponent piece we need to move because it's been killed by the red piece. And that's it. By following this logic, your Ludo game will be able to detect and handle kills effectively. Alright, let's start coding the logic. As mentioned earlier, the first step is to filter the opponent pieces. We will also make use of the variable called bonus reach. This will help us track if the team gets a bonus after a kill or it has reached the home. Next, I will set up a for loop. This loop will iterate based on the number of unlocked pieces for the current team. Within this loop, we will use the give array for moving path function to generate the moving array for the piece in the current iteration. This array represents the path the piece will take after the dice roll. I will then introduce a variable named cut. This will help us to identify the piece located at the last position of the moving path array, the critical spot for detecting a kill. Alongside kill detection, I will also add a check to see if piece has reached the home position of its team. Next, I will incorporate the kill feature for the user as well, ensuring both the bot and the user follow the same logic. Once the kill feature is working for both, we will implement the main action. When a piece is killed, it needs to be sent back to its respective starting position on the board. Here's how we will do it. First, reset the score of the killed piece to 0. Then, update its position back to its initial starting point. They got an error. It says cannot access array before initialization. Let's debug and fix this issue to ensure everything runs smoothly. Now that we are almost done with the project, there's just one last thing to configure. Moving the piece using the keyboard instead of the mouse. Here's how it will work. Suppose when I press a number key like 1, the piece with that number will move. First, let's add an attribute to the blue team. That's the user team. This will help us identify the piece the user can control. Next, I will set up a key down event listener on the document. And to roll the dice, we will assign a spacebar for that. For example, I press the spacebar to roll the dice, and the result is 6. Now, I can unlock the piece by pressing the number 1 on my keyboard. Once that sets up, the final step is to declare a winner. Here's how it will do it. First, I will create a div with the ID declare winner. Inside this div, I will add a child div that contains an h1 element for the winner's name and a button for follow-up action. Next, let's style this winner section. Make sure to copy the stylings I am providing here. To make it more exciting, we will add some confetti. Head to the Google and search for confetti.js. Open this repository, copy the seeding link, and paste it into your HTML file just before the script tag. Finally, I will write a function called declare winner. This function will take an argument team, which specifies the winning team. And that's it. With this, the game is fully functional and ready to play. Now that we have created the declare winner function, let's put it to use. We need to determine when to trigger this function. To do that, I will add a logic inside the move element sequentially function. Here's the plan. I will calculate the total number of pieces for the current team that are active on the board. If the length of this array is 0, it means all the pieces of this team have reached their home positions. At this point, I will call the declare winner function to announce the winning team. And that's it. Here, I almost forgot that there's an additional check I need to add to avoid potential errors down the line. I'm sure you understand why this condition is essential. It ensures that the game behaves as expected under all scenarios. Now, I will copy the same logic into the turn per user function and paste it there. With just a few small fixes remaining, our project will be fully complete and ready to go. To make the game more enjoyable, I will add some styling effects for the better user experience. These small touches can make a big difference in how the game feels. Next, I realize I forgot to include an important piece of logic. This is about changing the direction of piece to its home path when it reaches the home path entry element. If you remember the logic I explained before, here's how we'll implement this. First, we will identify the index of the home path entry element in the moving path array. Then we will slice the moving path array into two parts. Finally, we will merge these two parts to create a complete path to the home. This logic ensures that the piece transitions smoothly to its final destination. Now let's fix some small errors in the code to ensure everything runs flawlessly. By resolving these issues, the game will be ready to play without any hiccups.